All right. Double, single, double, triple. So we have H2, is that the one I used? Mm-hmm. O2. Everybody has this, right? Okay. I'm going to show you why these things form double and triple. And then we're going to get someone to do a little demonstration for us here. All right. So first of all, how many dots are in one bond? Two dots. I need to write that down. This is a single covalent bond sharing 2 electrons. If you were to do the dot structure, it would look like this. Dot X, that's 2 electrons, one from each. This is a double covalent bond. Sharing. Yeah. How many electrons are shared here? If one shares 2, 2 shares 4 electrons. If we were to do the dot structure for that, it would be dot, 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 x, x, dot, 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 dot. 4 electrons in between. And then you have a triple covalent bond. All right, Bella, how many electrons? 6 shared. Sharing 6 electrons. If we were to do the dot structure for that, that is the dot structure, but if we were to show all the dots, it'd be dot, 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 x, 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 dot, dot. So get all that down. Copy all that down. The notes and the dots and x's in between. I'll show you why and how those double and triple bonds form, and then who's feeling strong today? Who's feeling their oats? Who ate their Wheaties? Okay, Kara, you be the one that kind of shaker. I feel like that'll be fun.
I have a question. It's probably a stupid question, but how come?
Yep, it probably is. You're right.
Yeah. So, how come the dots are both on top of the O and bottom of the O, but not on the sides?
Good question. I'll get to that.
Okay.
Okay. It's a great question. Why do you think that was stupid? No one here knows that answer.
I don't know. I thought I missed it. I don't know.
No, you didn't miss it. Good job. Good question. All right, are we good? So I need you to really follow what I'm going to do next. Okay. All right. So I'm going to show you kind of the steps as to why O2 and N2 form those multiple bonds. Here we go. So I want you to copy it. First watch, then I'm going to have you copy it. All right. So if you take 2 oxygens, how many dots does each oxygen have? 6. So again, just watch. So I want you to pay attention, so you might miss something trying to copy it down here. So if we go, let's see, 1, 2, 3, 4, 5, 6, and then we put the other oxygen here. So 1, 2, 3, 4, 5, 6. So they're like mirror images of each other. Okay, so 2 here, 2 here, 2 here. All right. Does it do Sometimes my mind is going too fast for my mouth. What am I trying to say? Okay. Does each oxygen have a complete octet?
No.
No. How do you know?
Because there's a single dot.
There's single dots. They need to be paired up. So you could take this dot and put it here, but then what's wrong with this one?
It doesn't have an
It only has 2, 4, 6. You can do the same thing here, put them here, then that only has 6. So what it does to satisfy the octet rule, meaning it gets 8, a full valence shell, is this dot moves in here and this dot. They share those 2 as well. So if they're sharing 2 and then 4, right? So 2 X's and 2 dots, now both have 8. 2, 4, 6, 8. They share those. So this one has 8 and this one gets 8, and they both actually end up like neon 2-8. They share 2 electrons each. They each share 2 with each other. So that's 4 total. So that is why oxygen forms a double bond. And I want you to draw it. Put that right in your notes. Go ahead. And then I'll show you nitrogen. And we'll move on. Oh, if anybody wants a banana, you can have a banana too. I don't think I'm going to get your nuclear quiz graded for this quarter. I don't know. I'll try today. The grades are due tomorrow. Because the machine isn't really working correctly with the bubble sheet, you know, I got to grade my hand, which I haven't done in a long time. So it's just, I'm slower, obviously, than the machine. So just want to let you know. Because they should go on the second one. All right, so there's oxygen. Nitrogen. How many dots? 5. 1, 2, 3, 4, 5. Again, look up here. Don't take notes yet. Okay. How many dots does each nitrogen have, assuming they share those? How many dots does each nitrogen have? Count those 2 for each. 6. 2, 4, 5, 6. It needs how many? 8. If we start moving dots and X's around, we could give both of these dots to this nitrogen. Now this one has 2, 4, 6, 8. How many does this have? 4. That's impossible. That doesn't work. We could do the same thing here. Instead, what it does is it makes a triple bond. It takes this dot, this X, so now it looks like this. So again, you're just watching. Now it's closer. 2, 4, 6, 7. 2, 4, 6, 7. It does it again. This dot comes in here. This X comes in here. Now we have these 2 dots on top. 1, 2, 3 in the middle. 1, 2, 3 in the middle. And then goes on there. And technically, Reagan, the same reason here, these dots would actually be here. So I drew that wrong. That's technically how it looks. So that would be a triple bond. So go ahead and get that down. And while you're doing that, I'm just going to keep talking. You don't need to memorize this process. But it is important to understand why it forms the double and triple. I think it is okay to just memorize O2 as a double bond and N2 as a triple bond. That's the only triple bond you're really going to, if you're ever going to have to draw a triple bond, it's either going to be this or organic chem, which we learned down the road, which by the time we get there, it's not going to be a big deal. So this is pretty much the only one you'll see as far as elements are concerned. It is the only one. And then O2 is the only element that's double bonded. All the other Honkobriffs are single bonds. And then I think, didn't we do this last week, the CO2? Didn't we draw that in our notes? All right, and again, we're doing it in lab, so I don't need to repeat myself a million times, but you do need to know CO2 has 2 double bonds as well. So I'm not going to go through that step by step, but it's the same concept as this and this. Okay. All right. So no one wants to volunteer, huh? You gonna sacrifice Kara? All right. Feeling your oats today? No? Oh, that's unfortunate. Oh, here we go. This one. Whoops. Use this one. All right. Stand on up here. You don't mind helping, do you? Okay. Here we go. Hold that up. Yep. Okay. That's a single covalent bond. Okay. Go ahead and break it. Go ahead. Good. Good job. That was pretty good. Look at that. Probably hold that up to the last. Kind of like a signal. Okay. Now that's double covalent bond.
Break it again.
Break those now. That's what I say. I don't want you to hurt your hands, so just give it a shot.
Like break one like that.
Yeah, if you want to break one at a time, you can. I think you can do this.
God.
Want to use this? Don't hurt yourself.
This is hard.
It's supposed to be hard. Yeah, I'll do one, you do one.
Use your thumb.
I'm trying.
You sure? You want to give another shot?
I can't do it.
All right.
Because
So
my
now,
is a machine.
okay, hold it up like simple. Okay. All right. What's that?
A triple bond.
Triple. Okay. Now break those.
Are you kidding?
I can't either. Okay. Now. Thank you. Sit down. Good job. I want you to write down in like a sentence or two what was the point of that. So again, think about when she held up the single, held up the double, and the triple, and then think of the process of breaking them. What was the whole point? And then related, what are we learning about, right? What did we just write down? All right, tomorrow. So I want you to have an answer for me for tomorrow. It's like an unofficial homework, all right? So I'll call on somebody tomorrow. Tell me what was the point of that. Good job, Gary. It's not easy to break those things. Don't feel bad.